I'm going to try to, in mathematical symbols, talk about what my fingers were just doing. Okay? The low end, I took the IQR, multiplied it by 1.5, and then stacked it on the bottom of Q1. So I started with the value of Q1, right? And then subtracted 1.5 of the interquartile range. That looks awful. It really isn't that bad. And your TI does it for you automatically. And any program worth its salt will as well. We'll get into some of that in a minute. Talk about this. That's the low end. So anything lower than that is too small, quote unquote. And anything larger than this is too big. Kelly's thinking, my God, this is so much more confusing than 2 standard deviations. I agree, it is. It is. So why am I even talking about it? Why am I even talking about it? Why not just always use 2 standard deviations, Linda?
I'm sorry, this question. Is the interquartile range from Q1 to Q3?
Q1 to Q3, yes ma'am. IQR is defined to be the distance from Q3 to Q1 or Q1 to Q3, however you want to look at it. Yes ma'am. Sorry about that. Kevin!
I'm just guessing that you can use this with data that's not bell-shaped.
It doesn't matter if your data has a certain shape. The trick with the 95% within 2 standard deviations assumes that you trust the average and the standard deviation. If the data is highly skewed, I wouldn't, right? I wouldn't trust it if it's skewed. What's too skewed? Loaded question. Loaded question. Your call, right?
Right.
Your call on what is too skewed. Your call. I'll show you some ridiculously skewed data in a minute that actually grew out of a writing class. Super fun stuff to talk about. We'll get to that in about 10 minutes. Okay?
It must matter what you're measuring or what you're...
Say that again.
It must matter what you're measuring.
I think it matters more how much of it you're measuring, to be perfectly honest. This is just from a historical standpoint. If you are dealing with what's called a sampling distribution, Tom, and give me about 5 weeks on this, we'll get to it, I promise. You'll always use number 1. Because as soon as you start drawing, I think Bruce probably talked about this in physics with you, as soon as you start drawing a sample, bell curves magically appear in the sampling distributions. It's not magic, it's actually a theorem. But so assuming you can get a bell curve or get to a bell curve, you're going to be golden. Certain types of data align themselves better with one than the other, which is what you're saying. So generally continuous data kind of aligns with number 1, sometimes number 2, but definitely number 1 better. But we'll refine that as we go too. Very good point though. Any other comments, questions, concerns? No, we're good. Next data set. To the nearest 5 pounds, estimate my weight, which I hope I've never said in here. I've mentioned things about BMI and things like that, but I think I've hidden the actual number that I weighed from you. Nearest 5 pounds. You can count the hair. A couple pounds right there. And I just ate a banana. And some crackers.
160.
Oh, don't bias the sample. I'll collect it in a second, Jay. I'll collect it. Thank you. I'll collect that. I want to collect data. I want to do this, but I don't want to bias the sample just yet. Then I want to find out 2 questions. Number 1, what's the first question, of course?
Are you standing on her?
What, say that again. No, as a class, did you or did you not? Oh, maybe you don't know what I meant. Okay, good. You don't know yet. Good. We'll get back to